Hi, everyone, and welcome to a new Cloud Native Live. I am your host today, Taylor Thomas, a CNCF ambassador, and I just wanted to welcome you all to this awesome Cloud Native Live we have scheduled for today. As a note, Cloud Native Live is our generally weekly, but sometimes even more than that, live stream where we go into basically how everything works underneath the hood, how all the different cloud native technologies work and integrate with each other. And so, just as it is a CNCF, make sure you remember that it is governed by the CNCF Code of Conduct, which means just be nice and respectful to each other. So we're looking forward to having some great discussion and questions from the chat today, but please keep those questions and comments respectful. And with that, let's go ahead and kick things off. I'll let Gabriel introduce himself and the topic. So over to you.
Yeah. So I'm Gabriel. I'm leading the developer relations at Permit.io. Long years developers, actually already 12 years around software development. And for the last 8 years, most of my work was around permissions and authorization. I worked on network access permissions and then in a security operation room permissions on products, of course. And for the last 2 years, as I said, I'm working on a product that make permissions and authorization accessible for developers. And today we are going to talk about how to utilize OPA, Open Policy Agent, for authorization, or especially particularly fine-grained authorization at the best. We are going to go over the process and cons of using OPA. We are going to explain what OPA is for people who are not familiar, but I'm pretty sure this is a CNCF live, so people probably familiar with some basic for OPA. It's not an easy topic, but anyway. And we're going to talk about some more other open source tool like OPAL, Open Policy Administration Layer, that made OPA more accessible for authorization. And I think the main deep technical topics of this discussion is actually two topics. The first one is how do we decouple policy schema from policy data, which is something that would help us to write better policy and make sure that they are more reliable, because authorization and checking permission is something that should be super reliable and in our application. And the second one is talk about different type of consistency. Consistency is became very important when we need to design and plan a performant authorization system that we can decide and predict what permissions user will get per the data that we have in the system. And so that will be the deep technical topics that we are going to talk about today, but I'll keep something for later.
Awesome. Well, I'll let you go ahead and get kicked off with your various demos and things. And so, for those who are new to Cloud Native Live, this is a fairly demo heavy and on hands on keyboard kind of thing. So we're going to go ahead and let Gabriel show that all off.
Yeah. So let's start with, let me just share here. Okay, so Taylor, when I'm not looking at the screen and see us recursive, I'm not sure if I'm sharing the screen.
You're sharing.
So
You're
I'll
good.
ask you from time to time if you see the code, for
Yeah.
example, now. Yeah, so can you see the code?
Yep.
So
Everything's
first,
good.
great. First, before we start, let's start to define what is fine-grained authorization. Fine-grained authorization is very popular nowadays. It's something that is spoke a lot in articles when speak about application security, broken access control, by the way, or the vulnerabilities that happen because of a fault in authorization is the top one in every OWASP list nowadays. So authorization or check permissions for user, what a user can do is super critical in applications. And a basic authorization query traditionally looks like this one. We usually use roles to segmentize users. So, and we have if statement that say if a user admin equals to true, return true, and or just if not, return false, and do not continue for the following code. This is the most basic, simple, straightforward example for authorization. But if you ever wrote an application that scale, that is probably not enough, because you'll very soon get to understand, for example, that you need more roles for users to access this data. And the most horrible use case is that you have this kind of statement: if user is me, then allow everything, which is, as you can understand, really bad pattern. And with the data that we have in our application, we need to find a way to create more fine-grained permissions in our application by using more and more conditions. One of the basic assumptions of fine-grained is that we can, for example, use more attributes or more dimensions when we are doing authorization or permission statements. So one of the most straightforward of fine-grained authorization, if I allow the user to access only their own file. So I can ask, for example, if file owner equals to user ID, this is a very simple like fine-grained authorization because it returns us only one response. Sorry, it returns us only in resolution of one file in our system, right? So because we are comparing fine-grained resources, but with all the data that we have in our application, and since cloud native usually is very microservice by nature, it never ends up with this centralized authorization. And then we are very soon ending with maintaining permissions code that we just, overwhelmed with more and more conditions. Even if we have like a authorization microservice, then we can have this kind of if statements in our application code and in the authorization service, and just violate every rule of clean code or any kind of best patterns of software development. So the trend now with fine-grained authorization is externalizing authorization to a system or to software that is specialized with fine-grained authorization. If you are in the market, probably CNCF has two main projects that is specialized in fine-grained authorization. One project that we are not going to talk about today, but is worth to mention, is OpenFGA. OpenFGA is a project that made for authorization, for fine-grained authorization. It is actually inspired by Google Zanzibar. Google Zanzibar is a paper that described the way Google modeled their distributed authorization. The fun fact is that OpenFGA or any kind of Google Zanzibar inspired system is not distributed authorization, but centralized authorization system. OpenFGA has its own limitation, but today we are going to talk about another policy tool or something that can be considered authorization tool that is also a CNCF project. We are going to talk about Open Policy Agent. What is Open Policy Agent and why is actually relevant for a fine-grained authorization? Open Policy Agent is a multi-purpose policy engine. Policies and decisions are something that you actually need to do in any kind of software, not only for checking permissions of users, not only for check what a user can do, but also, for example, you want to get policy on how file structures, or the best example of Open Policy Agent itself is the Kubernetes gatekeeper, that you can keep admissions, you can keep what resources you want to deploy, etc., with Open Policy Agent. And with being in many opinions, the best uh, policy engine in the market, Open Policy Agent is also good for another form of decision. Decide what our users can do or cannot. How Open Policy Agent works. So you have first, of course, the agent itself, as you probably understood from the name, Open Policy Agent. Open Policy Agent is a piece of software. It's written in Go. You can deploy it however you want. You can deploy it with a WASM process into Helm charts, container, whatever you want. And you can also deploy it as sidecar. That's the way, for example, it's done with a gatekeeper, etc. So you just deploy a piece of software. This software get policies. The policies is what we see here. Policies is they are written in a Rego language. Rego language is a logical language that is inspired from languages like Datalog and Prolog. And by using this policy, you are actually configure rules. You are actually configure policy rules of what a user can or cannot do in our application. If you're looking on this policy, you can see this policy is aimed to model attribute-based access control, which is mean I want to do conditions based on attributes of my users. And you can see here the logical statement that say we are allowing the user to do something, right? We are allowing, it's just an abstract true or false question. We are allowing the user to do something in case the user is the owner. What does mean the user is the owner? If the user attribute title is owner, or if the user is employee, but also the action is read. And you can see here how the logical conditions are actually written. So that's the first piece of Open Policy Agent. We have the policies, we are loading them to the policy agent, and then the policy agent can get inputs. Inputs is actually what we are passing with the call when we are requiring the Open Policy Agent with what a user can do or not. Here we can see in the input that we are passing some user attributes. But not less important, there is also the data in the policy agent. We can load data that Open Policy Agent, or I'll call it OPA from now, will store for us and will allow us to load it in advance and run the permissions or run the authorization checks against data that is stored in the policy agent. Do you remember that I spoke about consistency? That's the main thing about the data that is actually stored here in the input, because here it looks very nice. We have these windows and we can click on evaluate and get the result true or false, right? We can, for example, change here to I know what are the other user. Let's say change to Alice, and then see that in the evaluation we are seeing different results. But in a
Hey,
real
Gabriel.
system, that
Sorry
yeah,
to interrupt. Can you zoom in a little bit? Some of the people on the stream are having a little bit of a hard time seeing the smaller font.
sure thing. It doesn't
That's
now.
that's better, I think.
Great.
Sorry.
So
Go ahead.
yeah, so as mentioned, we can run these policy queries or policy authorization checks. But in a real world, as you can imagine, it's not that easy to configure how this data is synced to OPA. And that will be, as I said, one of the deep technical topics of our live stream today, but we'll get to that later. But it was important to put what is OPA and how it works. So, with understanding these three pieces of OPA policy, like the policy schema that we are configuring here with the Rigo language, the input, which is the context of the request itself that we are checking the permissions for, and the data that is stored in advance in the policy engine. That's other one side of the authorization. But the other side is that since we actually outsource or externalize our authorization service, probably don't want we want to ensure that we are not coupling or duplicating the condition themselves to our code, because what could happen potentially is that if someone don't know Rigo well or not familiar with our authorization, they will try to write more and more conditions in the imperative code. This is why we want to keep the pattern of the enforcement function. The enforcement function that we are going to mention here is the check function that get three arguments that also consider as SAR, S-A-R. SAR is subject, which is the user that we are trying to authorize, the action, what they are trying to do, and the resource. Following enforcement function that always have only the SAR, the subject action resource, and potentially also context like what is the time now or for stuff like that, but it's not necessarily. But keeping the three argument will ensure that our code would never leave conditions. The patterns that we want to keep is that when we actually sending a query to OPA, it will not look like here that we are actually here we also sending the user action resource, but potentially we can send more stuff. So the first pattern that we want to keep our external authorization service very clear is to make sure that OPAL is allowing only this, that OPA is allowing only these arguments. And again, keeping these check functions with these three arguments can also help us with reading better or with authorizing better our users. Another function for authorization that we probably want our users to have with OPA is filtering. We are not always going to check for permissions. Sometimes we want to have the list of all the permitted resources. For example, here we can see also that we are having the user, the FGA user, Here's the tenant, which is technical stuff, and also the IDs of the resources that we want to filter. By using these two functions, we can really separate the duties between our authorization service that will get the decision of what a user can do, and our application that enforce the decisions that get in this externalized authorization. So first lesson for today is that if we want to keep OPA, which is multi-purpose engine that can and can have multiple ways to check permissions, if we want to keep it clean and ensure that we are maintaining the separation of duties, we want to keep the check functions as clean as possible. The second thing, and we are going back now to the playground, is keeping permissions model. If you look here on the example, you'll be able to see that with OPA you can do a lot of stuff. You can write policy with any kind of rules that you want, and OPA will do the calculation and return. But when you need to streamline it and have it for multiple users, you probably want to have a permission model. A permission model, you can think about it like design patterns of permissions that you can teach your developers, and you can streamline for so people will understand that later. And not only that, that first step in keeping our policy schema clear. As you can see here, Rigo is not a language that is easy to learn, and we will not have many users in our organization that actually know and know better and know well how to use OPA. And we really want to keep the understanding of OPA very clear, because if we'll have someone that really understand OPA or think that they are understanding OPA, they can create here rules that are not coupled or not connect with any kind of the pattern that we have in other areas of our system. And this is why it's important to keep an access control pattern that are familiar. What are these access control patterns? So we can see here in the example three examples for that. So first one is role-based access control. Role-based access control is actually the most familiar and known, I think, access control or permission model out there. It's a if a user has a role, you see some grant in user is grant, then they are allowed to do action in some resource. Right? Role-based access control is very simple. It's segmentizing the users in roles, and the roles has permissions. The main problem or the main issue with role-based access control is not really fine-grained. It's coarse-grained because we cannot have the resolution of the particular resource or the particular subset of data that we actually want to authorize our users for. We can have some patterns on top of role-based access control. So for example, we can have a hierarchy role-based access control that we can see an example here, that we can have users to inherit other roles and other permissions, and then we can make it a little finer. And we can also use some, for example, some things like tenants in our application, and then we can assign users a role in tenants, and then we can have a finer resolution, but yet is not that fine-grained. Fine-grained, for example, is what we saw as attribute-based access control, because here, for example, here we can see the tenor that is more than 8, but we can say, for example, data user attribute. We can, for example, have here also a resource, and then we can compare, like, so for example, pet is adopted. We can see that is true, but we can also do something like person user is owner, and if data pet attributes owner equals data user, or like input user, for example. Yeah. And here we can, for example, compare if the pet attribute owner, which of course does not exist here, is actually the input owner. And then we can get fine-grained authorization using attribute-based access control. If you want to go more fine-grained with OPA, we can also go with relationship-based access control, which do not have an example here, but we'll get to that later. Relationship-based access control say, if a user has a relationship directly to our resource, they are getting permissions. But not only that, since we can model resources in a way that they are actually related to each other. So, for example, files are belongs to folder, or widget is part of a dashboard. A particular, of course, a particular instance of a widget is part of a dashboard. Then we can traverse this graph and say, if a user is owner of a dashboard, then they are also a viewer of all the widgets that actually related to the dashboard. We will not show the policy here. And the reason why we are actually not showing that here is because it is not easy to achieve it with Rigo. As you already understood from what we're seeing here, Rigo is not that easy to use. One of the things, by the way, that is really helpful with Rigo is the linter. Rigo has a library called Regal that can help you with understanding what you do with Rigo. You can install it on your IDE. This is the library, and that can help you with writing Rigo. Of course, if you're using like Cursor or Copilot, that could even help you better. But we'll get to Reback later. First, let's discuss about the problem of having all the data and the input and everything, and the policy itself synced to our policy agent. Until this point, we've been in the playground. In the playground, it's very easy to run stuff, right? We can write the policy, we can put here the mock input, and we can write here the data that we want to have. But think of a real application, right? So you have like architecture, and this architecture is, let's say, Kubernetes cluster. You have 3 microservices. Each of them need to do authorization services. Each of them need to do that fast. So that means first you need to have a separate sidecar of Open Policy Agent for each node that you have, right? For each microservice, we want to have an agent that can authorize user. Then you need actually to ensure that all the data is synchronized to this agent. So deployment OPA can be a nightmare. And this is why we develop OPAL. OPAL is Open Policy Administration Layer. And Open Policy Administration Layer is developed with a strategy or approach that believe the real problem with fine-grained authorization for product developers, for application developers, is not the policy itself, is not the decision itself. There are great policy engines out there. OPA is doing a great policy engine. OPA is doing a great policy decision. Do it fast. You do it very efficient, and at some sort you can even verify OPA decision to be in the time that you actually want them to be. But the main problem is, how do I deploy that, and how do I make sure that actually all my policies are always synchronized with all my sidecars that actually getting the decision, and how the data is synchronized to that. So OPAL, the Open Policy Administration Layer, is a tool. It's written in Python, but can be deployed, of course, in any cloud native
Can you zoom in a
way
bit
that.
again, Gabrielle?
Yeah,
There we
here
go.
we go. Great. Oops. So I'll get back to OPAL. So OPAL, again, is a tool that is built in Python, but you can deploy it in any cloud native way that you actually want to deploy that. And what it does, by very simple configuration, it deploy a server, which is a centralized piece of software that, of course, can run as a node. And this server node, the first thing that they know is to connect to a Git repository where you are actually storing your policy schema, right? What we had here need to be stored somewhere, and probably that will be a Git repository. So the first thing about Opal, it knows to connect using a GitOp mechanism to your Git repositories, and make sure that your policy engines are always the policy agents are always in sync with the schema that you configure in this Git repository. Then Opal has a deployment mechanism for Opal client. What is Opal client? Opal client is a sidecar or a small container or process, whatever you decide, that is contain, of course, the policy agent itself, the open policy agent, but also a wrapper. what is this wrapper doing? So the first thing this wrapper doing is, of course, connecting with the OPAL server and make sure that the policy schema is always in sync with the client. So you can ensure only by deployment and connecting to the Git repository that when you deploy the policy and you do changes for the policy itself, it just propagate and synchronize with the policy agents. The second is the data. If you remember, we have a lot of data here. And here again, in the playground, the data is just look like a simple JSON. But in reality, the data is stored in databases. The data is maybe fetched from API, could be the paid tiers of your users. It came from many data sources. So the wrapper is now to get configuration of what data do I need, not the data itself by configuration. The configuration is only what data do I need, and then the client knows to fetch this data by the mechanism that you actually choose and make sure that the OPA is always synchronized with the data that you need. So if we look now on if you look here on one of the examples of the policy of the Docker Compose that we have here, let's wait for this page to load. We can see that with one Docker Compose, and again, you can deploy it whatever you want. The Docker is actually the easiest way, to demonstrate how these things work. So, for example, let's look on Docker Compose with Kafka because that's interesting. But let's start with the OPAL server. So you can see here we are deploying the OPAL server, and then we are just configuring, technical deployment stuff. And we also here have the OPAL policy repo URL, which is the URL where we actually going to store our policies. So instead of worrying how the policy agent will get these policies, we are just loading the URL here. And we also have the data config sources, which is, as I said, is the configuration of where we are going to get the data from. Here you can see, for example, that we are using the HTTP fetcher. HTTP fetcher is just the simplest that we can imagine. It's just know how to fetch data from HTTP servers. And the most interesting thing is the OPAL client. In the same automatic way, we can deploy as many OPAL clients that we want. Again, here we are only have one-to-one, but in most of the application, that will be one to many. And you can even configure that one OPAL client will get one portion of data or will fetch one portion of data, and another OPAL client will fetch a different set of data. So it can manage the way that Open Policy Agent do authorization across multiple instances and multiple deployments. What is the Kafka here? So we need to keep in touch between the nodes, right? So we have here the data that we are synchronizing into all the OPA client, and it is also configurable how this data is fetched between the server and the client and the instances of the server itself. We can also deploy many servers to clients, and we can set up ourselves the data fetch, the broadcasting between them. Why is that important? Because we maybe want, just use our existing Kafka instances to also send the relevant data, and that could really seamlessly integrate as authorization service, even in a traditional system. One of the things that I personally like about OPA is about modernizing systems. Many times when people understand they need fine-grained authorization, they're like, okay, but I need to plan a migration now, and I need to do 6 months of migration from my old homebrewed authorization to the new one. And with OPAL, because it integrates seamlessly with the moving parts of your system, you can decide, for example, that you are deploying only one decision, make sure that all the data is fetching in the right way, and ensure that you're solving one problem at a time, and not like, for example, deploying raw open policy agent that require you to think about it. Another thing about OPAL, the Open Policy Administration Layer, it can run more policy agent. For example, CEDAR. CEDAR is another policy engine. The main thing about CEDAR, I'm not going too much to that, but the main thing about CEDAR is that a verifiable engine. If you have a super performant policy, then you can verify how much the permission will take before you are, and what of course will be the decision before you are actually doing that, and that can help you keep performance system. So OPAL is actually generic for the policy store, but most of the users that actually use OPAL are actually use that for with Open Policy Agent. As you can see, there is a very large community around OPAL. You can see the stars, and I encourage you to give it a star too. But you can see there is a lot of people using OPAL. There is also some name dropping here. And of course, OPAL is the core for Permit.io, the service that we have for our authorization. Another interesting thing about OPAL is the data features that we have. Probably, as already shown, you can fetch data to OPAL, use HTTP. But you can you need data from multiple sources. So OPAL is actually pluggable for the data fetchers. You can see the documentation here on how actually do that. But there is community contribution of more features. As you can see here, there are already features from PostgreSDB, LDAP, whatever you need actually to fetch data into OPA. People are actually writing and contributing. If you are looking for a contribution due to the Oktoberfest, then I'm inviting you to write an OPAL fetchers that will be able to fetch more data into OPAL and help other create better fine-grained authorization system. So OPAL is actually help us to solve the first problem, the problem of how we are actually taking all these three very, I'll not call it like naive data schema and input that we have here into production, into a way that you actually can run it as for authorization in production. Of course, similar to OPAL in other places, we can see libraries that do it for admission, like Gatekeeper, etc. But for authorization, OPAL is actually help you to take or provide you an end-to-end fine-grained authorization service that you can deploy OPA with. The second issue with OPA, as I mentioned, is actually the Rigo. But Rigo, the main problem or the main challenge with Rigo that we found in Permit is not the complexity of the language. The complexity is something that you can learn. But Rigo internally has an issue with the way that you are actually separating the data from the schema. If you want to scale your authorization service, then you want to make sure that you are not coupling the data that you have from here too tight into the policy itself. For example, here we can see that we have a data per attribute, and then we check the resource, and then we are accessing directly the data. Now, of course, this is fine. You can't write a policy without take a look on the data. But when it got complex, it is very easy for people to do, for example, data manipulation and data that is actually create a lot of complexity for the authorization layer. And authorization layer is a very, very sensitive thing. We found that, for example, for one API endpoint, the average authorization calls that a usual software do for one API endpoint is between 3 to 5 calls, depend on the industry. In fintech, you will get more than that. For example, to do one transaction in a bank or for fintech scenarios, you can get into a loop of 10 calls to the policy engine. So it makes it really sensitive. And you want to keep your code, your authorization code, very simple. The way to keep it simple and the abstract way to keep it simple is of course separate the schema. We already decided we are going to use permission model like attribute-based access control, role-based access control. So that help us to understand how we want our policy schema to look like. But the other challenge is how we are keeping it for a long time. Conditions get more complex and complex, and we want to keep it in one or at least 90% of our policies. We want to keep it in a very simple way. This is why we came with a terraform provider to generate Rigo code. I know that sounds that maybe not sounds that friendly, that I'm going to write a code that is converted to a policy as code because I want to write my application only in one language. But writing your policy code in Tofu or in Terraform would help you to keep the schema very clean, because the difference between logical language and declarative language is that declarative cannot let you handle any kind of operations. It's not operational. Logical can let you, for example, have if statements. You can have, for example, loops, etc. Declarative language limited you to have only declaration. This is why infrastructure as code is so popular, because you really want to make sure that all the operations is made by the tool and not by the code. And this is why we felt that the right way for someone who want to write fine-grained authorization and use OPA is actually to not use Rigo, but to use Terraform. So this is why we created this Terraform provider. The particular piece of the code that is generating the Rigo from the Terraform using the Tofu is not opened yet, but we are planning to open that soon. After we'll make sure that is really we are really stabilizing it. But let's take a look what we are seeing here. So if we remember, we saw in the Rigo with everything was logical, but here we are going to declare what we have in the system. This system is a system that trying to authorize a user to view visit. Think about like a healthcare, for example, healthcare organization that has a lot of visit, and we want to check if a user is allowed to view visit using some conditions. So let's see what we have here. First, we are declaring the visit itself, right? The visit is has the action of read, because that's the action we want to have. We try very simplify it. Oops, I haven't planned that. Let's open it again. Okay, so the visit has the action of read and also has attributes. The attribute will help us with fine-grained authorization. So, for example, diagnosis, for example, a practitioner, concealed, and that will help us to create conditions later. We also have a resource of diagnosis and we have a resource of practitioner, all in the same way with the same action. As you can see here, instead of implementing the condition inside the resource, as we, for example, did here with the pet attributes, we are just declaring the resource. And then we can have conditions. Conditions, for example, this condition is a resource set that we can have condition of resource concealment equals to false. Now, the difference between declaration of condition and imperative, not really imperative, but a condition that is actually has effect from external mechanism is huge when we want to scale that. So we have this file. I'll not go over one of each section of this file, but let's see what happened when I'm running it. I'll do the show here. And I'll run just the usual tofu to apply it in my repository. So as you can see here, the init is starting to run, and we are actually see here that we want to add 28 resources that will actually generate a schema for us. Let's go for a second to the repository where we are actually storing the permissions. So you can see here, for example, we have a repository of Rigo. Let's go for example, to generated ABAC. We can see that we have nothing here. After I'll approve that, the Terraform provider that we created will generate the Rigo code for us. And if we'll back to this folder or some other, we can see that we have here the new condition set. Let's look, for example, on the resources that we have here. So we have the permit one, and we can see here that we have all the ABAC policy that we created. The thing that the Terraform provider helps is that this code will never change. We'll always have the basic code in our repository that help us to do the baseline permissions, and all the configuration that we actually need to deploy to our system. For example, here, a visit that is allowed is generated by a declarative code. And this is how the Terraform provider is actually helping us to achieve a very clean code with the Open Policy Agent. Now let's discuss the needs of the system and how can we keep clean data with our system. So let's first understand the requirement for this repository. So as I mentioned, the repository, should I make it larger, Taylor, or that's clear enough?
A little bit larger might help, but I think it might be clear enough as well. So yeah, that's
Mhm.
probably good right there.
Fair. And if you have any questions, just remember that I'm not in the recursive screen. So
No,
I
if you
mean,
want to pause now, there are a few questions. I've just been waiting for a good spot. So if you want to, there are a few questions. I can
yeah.
feel.
So let me just summarize a bit so we can get back later with a better perspective on what we are doing, what we are going to show. So until this point, we discussed about how to use or why OPA is very good for fine-grained authorization. We explained how OPAL can help you deploy Open Policy Agent as an authorization service. And then we show how writing custom provider to generate the Rigo code can help you with keep a very clean and stable Rigo repository. And the next chapter will be how can we keep better data sync and data consistency with the policy that we actually need to run. And yeah, let's go for questions.
Let's go ahead and do a few questions here, and we'll jump back in a second. So, one person was asking about using Vault with all of this, especially since it's or OpenVal, right? Because you're using OpenTofu. Were is there any things about how like Vault can tie into maybe some of this as well that you can answer, or that if you're going to show it, you can just say, "Oh, I'll show it in a little bit." But
Yeah, so I'm not sure if Vault has. I assume they are talking about HashiCorp Vault, right?
yes,
So
that's what I'm
just to make
assuming as
sure that,
well.
yeah. So HashiCorp Vault is a very good tool for storing stuff, but not to make decisions on top of it. For example, if we are thinking about, just we want to keep user secrets, there is no real effect on the way that we are, as far as I understand. Maybe I see it's a Dr. Party. Maybe Dr. Party has some other insights on how we can connect Vault with OpenTofu, but as far as I know, I mean, it's just connected. But I mean, Dr. Party, if you can elaborate of how use, what do you mean by using Vault plus OPA? We'll be happy to learn more about it. One direction that I can think about is I know for admissions, you probably want to use Vault, for example, to make sure that you are deploying only the safe stuff and secure stuff. But this is not the use case. The use case here that we are doing with OPA is for product authorization, for user authorization. So no admission part of Open Policy Agent.
Awesome. And
Mhm.
then there was another question around someone just said, thank you for the open overview of the open policy agent. And then they said, sounds like it's going to be a must use in Kubernetes environments. And I mean, I know the answer to that, but like, because I know there's a bunch of people using it, but I think a good way to interpret this is what kind of production use cases are you seeing of people using open policy agent with and its related environment inside of Kubernetes?
Yeah. So first, one of the things that is the, I'll talk about the marketing perspective of Open Policy Agent. Open Policy Agent is not a native Kubernetes component or something like that. It's a very good multi-purpose policy engine that you can run everywhere, right? One of the business approaches of Open Policy Agent by the company that created Open Policy Agent is use it as gatekeeper and admission controller for Kubernetes. This is why many people directly connect Open Policy Agent. But to do authorization for Open Policy Agent, you can do it in any kind of cloud environment you run or even on-prem. At the end, you are getting either a process or container that you can run next to your application to get policy decisions. It's not about Kubernetes. It's not even related to Open Policy Agent or OPA Kubernetes project like Gatekeeper. It's not part of this one. The idea here is to take the core, the engine itself that can get decision, and build on top of it a service that allow us to do fine-grained authorization.
Awesome. I think there's one more question here, and then we'll let you get back to finishing up that demo. Um, Someone asked about how like partial evaluations and policies can be tested to make sure they're implemented correctly, and like what kind of automation and testing methods are available for these kind of tests.
Yeah. So I'm really happy for this question, but I'm not that happy. I'm not that happy because I really want to back to the demo because I see another question came and that's actually part of my continuous demo. But this one I can talk about it for a long time. One of the hardest thing about running OPA alone is about testing. You have test capabilities with OPA, you can test policies, but it's really hard to connect it to your real data or even mock data. And this is where OPAL can actually really help you because OPAL is using GitOps and you can have, for example, test branches for policies and then mock data from multiple sources. So think about OPAL also as an enabler that can help you test policies the same as you are testing any other component in your application. So you don't need to run any special tools to run OPA tests or any special wrappers. You can just plug OPAL into testing branches in your Git, in a policy Git repositories, connecting OPAL client or spin them up with the test configuration and just run your usual end-to-end test with all the capabilities that OPA can give you on the result and the audits. I'll read the next question because that actually could be a very good intro to the to the 10 minutes that we left. It might consider a good approach to pass all data as input to the policy evaluation request instead of fetching data from data source or keeping them historic and aligned in OPA. That's a great question, and that led me to the next phase of the trade-off of or consideration when using OPA, and this is actually the consistency of the data. Okay, so I'll share again the. Let me share again the screen. Can you see the right? This is
Yep,
the
you're
FGA.
good.
Yeah, that's the one that we already show. So let's talk about our use case. In our use case, we have visits, which is a collection of visits that we actually want to filter. Each visit has attributes like appointment ID, practitioner ID, diagnosis ID, and concealed. Concealed mean this visit is concealed. Then we have diagnosis that, as you can see, can be related to a visit. Each diagnosis has concealment that is false, and practitioner has is advertised true. To consider a visit as allowed, we need a visit to be concealed false, a diagnosis to be concealed false, and a practitioner to be concealed to be advertised. If we're looking, for example, on a Rigo code that do for us this comparison, so we can see this allow statement. So first we are checking this input is visit, right? Then we are checking that it says key because that's important. We can understand what is that. And then we have one condition for allowed visit, right? So for example, we can see here that a visit, allowed visit, is a visit that appointment ID sorry, allowed visit is a visit that is not concealed. We can see here that we also iterate over the diagnosis and check if they are not concealed. And we can also check if a practitioner is advertised. Right? It's a long Rigo policy. And of course, this policy can help us understand how better is it if we can write this provider or use the permit provider that will generate you the Rigo code, because here you just declare that you are declare a condition of non-concealed visit, and then you can even have a condition for a foreign key, so we can pass only the visit, and then we can have foreign key condition that say if the practitioner ID is advertised equal to true and the concealment equals to false on the foreign diagnosis, and of course the visit, of course, concealment equal to false. Look at this condition. Sorry, that was long way scrolling. Look at this condition and see how made it declarative, made it much easier than write it on Rigo. And the Rigo that you actually see here is only partial Rigo. Actually, you'll need to have fetching all the data. But now that we want to discuss about how this data happened. So when talking about data, let's talk about consistency, because that will be the factor that we consider when we actually want data. Consistency, of course, has effect of on performance, like the user from the Q&A mentioned. Let's look here on three methods of how we can run this policy using three types of consistency. The first type of consistency is so-called read-write consistency, or read your rights consistency. And this is actually what our friends offered to do. So if we look here, as you already saw, we have the schema. We need to synchronize our data. Let's take a look on this. Where is this? Oh, sorry. Clear. Oh, yeah. So let's look here. Here we can see the bulk check that we are doing, right? Let's not go over all the code here, but let's say that the user, we are allowing all the user to do read, and we just check the resources themselves, right? So as you can see here, we are sending the attributes as the context of the input. This is what our friend actually proposed. This is create as read your rights consistency. That means the data that arrives to the replica, the data that arrives to the open policy agent, that's the data that will get the decisions based on, right? That will be the data. The problem, there is two problems with this approach. First one, sometimes we want to have distributed a policy agent, and we want to get distributed decision based on. And when we do read your rights consistency, means send all the attributes in the context, that create a way that we can't trust the others, right? So that's the first problem. The second problem is that we are creating a level of complexity in our application. As you can see here, as you can see here, I'm very sick JavaScript developer because you can't understand anything that I wrote here. Probably if you're not very familiar with all the destruction on JavaScript. But as you can see, the complexity here. So first, we have to give all the visits and also all the diagnoses. We need to. Someone popped up on the screen. Can you hear me and see me well? Right.
Yeah, you're still good.
Great, great. So as you can see here, we need to get all the diagnoses and filter. It could be, of course, it could be more efficient in the way than the way that I did it here. But every time that we are actually checking permissions, we need to check them against the all the data. So read your rights has its own benefit. So you can ensure that what you sent is what you get, but has two problems. First is with distributed system, that you don't know what happened on other nodes of your agents. And second is that your application need to deal with the complexity of the checks themselves. The other option is eventual consistency. Let's take a look on what we are doing here. So here we have this flat sync. If you think about it, the data that we need to synchronize to the engine is actually only the diagnosis and the practitioners, because the visit is what we are actually filtering. We can synchronize it, of course, but in this example, as you can see here, we are creating resource instances. The APIs that I'm using here is an abstraction layer on top of OPAL. But what it will do, it will just send the data to OPAL using the permit data fetcher. And as you can see here, we have we are creating an instance for each of the objects that we have. What we are creating here is actually, and that's the default way that OPAL is actually work, is eventual consistency. When we are running the PDP, when we are running the open policy agent with OPAL, we can configure one of two eventual consistency way. The first one is eventual consistency by default, that is not waiting for updates. The update is, of course, happened very fast, but if we will try to run and we'll have like a slow network and we'll try to run the check just after synchronizing all that with the OPAL server, that will synchronize them to the open policy agent, we can get a wrong consistency. We can have wrong correctness. I hope that's the right term to describe it. But because we don't know what happened, the OPA know, and we can also have a flag in the OPAL client that say, I want eventual consistency that will wait for update, but that will be eventual consistency. So you can do it for most of the cases. That's the way you want to go, because that will be really fast. A decision that will arrive will not have your application to deal with all the data, to synchronize it or to fetch it, to send it with the check itself. But it's eventual. For a very performant and sensitive system, it will be hard to use that. And this is why OPAL is also giving you an option for strong consistency. So if we're looking here on the if we look on the flat sync, we can see an option to run the data sync instead of against the OPAL server, against the OPAL client, and achieve strong consistency. So as you can see here, we are enabling the PDP with proxying the facts, proxying the data on the OPAL client. And instead, this client, instead of sending it to the OPAL server that will propagate it to the OPAL client, will send it to the OPAL client. The OPAL client will inform the OPAL server that they need to update all the other agent. And every time that we'll synchronize data, we can also configure how long we want to wait for that. This wait for sync allow us to create strong consistency, because we can ensure that after we synchronize the resource instance to the OPAL client, all the other OPAL client and OPAL server are actually knows to wait for that, and we get a really strong consistency. I recommend to do that only for critical updates. Most of our authorization decision are fine with using eventual consistency, and I say that with with a little humble, but with a long experience and seeing a lot of authorization use cases. But to summarize, and I know we do not left that much time, we can have three types of consistency using OPAL and OPA. We can have read writes consistency by using the attributes on the check function itself. The cost, again, is performance and dealing with our application. We can use eventual consistency that is configurable if you want to wait for the updates or just know that the update happened. By the way, you can also get in the result of the policy check the check from the old consistency, the check from the old version, and also a message: this this data already has a new version. You might want to do it again. So this eventual consistency, which is balance between both, and there is strong consistency that you can ensure that the data is updated, but you need to wait. You need to wait. If, for example, an update is just arrived, the PDP will wait that the update will end and only then return. So it's good for very sensitive or for very critical data updates, but it could be it's not cost effective for most of the use cases. I think that's the this is what I wanted to demonstrate today. So again, the last part of the demo was about the consistency type that we can have and how we want to actually synchronize data into OPA via, of course, OPAL. And yeah, thank you very much. And I'm not sure how long we left for questions, but
We're almost at time, but we did get some time there in the middle to answer some questions. I haven't seen any more pop up yet. But before we start wrapping up, Gabriel, did you have any calls to action or things you wanted people to do, or like where they can contact you? Any of those kind of things you want to leave people with?
Yeah. So first thing is fine grained authorization is not that it's not as hard as it seems. There are many tools that can help you with that, especially with OPA that considered a tool with a high barrier of learning. It could be easy to use by using some other tools. I'm really encourage you to visit OPAL, the Open Policy Administration Layer. Now it's Oktoberfest. You can find their good first issues that you can contribute. I also invited you to the OPAL community. We have an OPAL community. I can send the. Let me send you the link so you can share that. If you have any questions about OPAL, the community is, I think, more than 2,000 people. Many of them, use OPAL in production. And no, that's not the right link. Sorry, Taylor. That's the right link to the Slack community. you can join there. You can discuss. You can find me there, or you can find me on LinkedIn or Twitter or whatever you want. And yeah, let's keep our users secure and do great software.
Awesome. Well, Gabriel, thanks so much for coming today. This has been a great presentation. And also
Thank you.
thanks to everyone who asked all the questions and was contributing to this discussion. It was great to see that. And